A little taste of it. So notice it's a series and you have n in it and x, right? So that's how it's going to be for these next ones we do in the next unit. The n is what's going to infinity, right? So that's like your counter. Your x is like the variable because this series you can usually translate into an equation and vice versa. So we'll go into all that stuff next unit. But as far as this is concerned, is you need to find the values of x that makes the series converge absolutely. So we kind of bypass the like alternating series test, because if we do ratio tests with the absolute value and it's less than 1, then it's for sure absolutely convergent. So essentially, we kind of go straight to the big guns in a way to figure out what that x could be. So it's honestly just hardcore algebra and hardcore limit taking. So what you do is you do ratio test. So I usually do the n plus 1 on the top. You don't have to, or actually, yes, you do. So you put the n plus 1 on the numerator, and then the denominator is like the original. And then what you do is you can evaluate the absolute value with the negative ones. So like my next step would be n to infinity, and then I usually do the multiply by the reciprocal thing. So it ends up being n plus 1 and x plus 4. Plus 1 all over 6 to the n plus 1, and then multiplied by the reciprocals. But essentially, I just took out the negative piece of it for that. So it would be n x plus 4 to the n. Absolute value less than 1. So you're solving an inequality. So yes, it's annoying to rewrite it, but it's necessary, okay? So you're going to keep having this less than 1 because I'm trying to figure out, because if this limit is less than 1, then it's absolutely convergent, okay? So now we just have to think, okay, we can do this, right? Yes. So I'm going to keep the bars here, so I have to cross-reduce some stuff. So we've got, maybe I'll do the n junk together. I think that's what I'll do. So what do we have here? The n plus 1 and n can't do anything, right? No, that's sad. That's okay. The n plus 1 and the n. So if I'm just focusing on the n stuff, that's what I'm kind of working on right now. And then if I look at the 6's, I've got an extra on the denominator, right? So that's here. So I did all the stuff with n's, or I kind of keeping the x's separate. And then with the x's, how do I want to do this here? This is kind of the same thing as the 6's. You know what I mean? Because you've got n and then n plus 1, so you've got an extra 6 down here. This is like the same thing, but you have an extra x plus 4 on the numerator, right? Because you have plus 1 on there. So I'm going to put that over here. Is there any questions on how I simplified that? No. Okay, so now basically what you do is you take the limit for n, because n is the one going to infinity, so you don't touch any of the x business, okay? It's really you're focusing on this piece right here, because that doesn't have any n's in it anymore, that x plus 4, which is exactly what I want. So really you're focusing when you're doing the limit is just on the n's, okay? So if you do that, you get what, 1/6, right? So what ends up happening is now that you took the limit, okay, you still have your absolute value bar, but you have 1/6 and then x plus 4 less than 1. And then now it's just turning into like algebra absolute value stuff. So with the absolute value being less than 1, that means this value to clear the bars has to be between -1 and 1. Right? Because like this could, like in here, this could equal negative 0.5 because of the bars. You take the absolute value of it. So you need a number between negative 1 and 1, and then now you're just solving it like old school algebra. You know, multiply both sides by 6, subtract 4. So the values that make this converge absolutely is between negative 10 and 2. When x is between negative 10 and 2. So it's just more algebra. Yeah. Because I'm saying, like, if this whole thing was equal, say, to negative 1/2, that would still work. Or negative 5/6. Like, that's how you would solve, like, an absolute value question. So, any question? This is good. Hey. So, same with this guy. Yeah.
Absolutely convergence on that.
On that interval, yeah.
Everything else is conditionally.
That's next unit. So, yeah. We'll learn that next unit, don't worry.
So this stuff isn't going to be on.
No, it will be. It'll just be on the interval. You're just going to have to find it.
So we don't have to write anything?
Nope, it's just straight algebra.
Is it always going to be negative 1 and 1?
Yep. Well, like, okay, look at this. What would that be between? Wouldn't that be this? Remember this? It's algebra 1, but that's okay, you guys. We've definitely done this in algebra 1, but that's okay. We're going to be fine.
Did you do one? I thought it has to be less than 1 to be converse.
Yes. Yeah, because so by ratio test going way back over here, it converges when it's less than 1. So when you do this on an alternating series, it means it's absolutely convergent. Okay. No, that's good. Right. Wait, just for fun. Do you know what this one is? Just think of values that would work. Would negative 3 work?
Yes.
So x has to be less than negative 2, or x has to be greater than 2? No, you're going to need this for, guys, this is really old, like 13. 13. Yeah. Okay, do you know what absolute value is? What's the absolute value of negative 5? 5. Okay, so would negative 5 work? Would positive 5 work? What about 1? Or negative 1? No. Okay. Oh, that was fun. Okay. Yeah, you did, but it's, you know. All right, so this is the same thing. Okay. So for it to converge absolutely, notice this isn't even alternating. Okay. Well, I guess technically it could be, depending what your x could be, right? Because it could change from positive to negative. Because think if that was like a 5. If your x is 5, that'd be negative 4 to the nth power. Guys, can we please stop the side conversation? So if we plug in like a negative 5, that would be an alternating series. Do you see how that works? Because you have negative 5, or you have negative 4 to the nth power. So this technically could be alternating. So again, finding when you see these directions, find the values of x that makes the series converge absolutely is you're using ratio tests. Unit 10, your ratio test is your best friend. Okay, because if it's less than 1, it converges absolutely. So, and we talk about what's called a radius of convergence. It's going to be fun. Okay, so what you're going to do is this ratio test, which the first step is super annoying, but it's fine. We're going to be fine. And you're going to do the n plus 1, right, over n plus 1. And then your original guy is x minus 1 to the n all over n. And then the bars. And we're solving an inequality. Okay, so you're not saying that's equal and you're doing more limits, okay? You have to show that this is less than 1. So it's like this is the inequality you're solving. And you're doing like each line less than 1, less than 1, less than 1 each time. So here we go. Have to rewrite it again. Isn't that fun? Over n plus 1. And then multiply by the reciprocal. Make that less than 1. And then you do all your reducing. So usually I do all my x stuff together and then all my n's together. So I don't do anything goofy like plugging infinity into everything. So I usually like put all my n's towards the front. That's just me. So like, well, that doesn't even cancel. So that was anticlimactic. So this guy, nothing really happened. I can't divide that out. But I can with the x minus 1s. So the x minus 1s, I've got an extra on the numerator compared to the denominator. So this is going to be x minus 1 left over. Less than 1. Is everyone okay? So again, this is just me. You don't have to do this. I usually like to put all this n stuff over here because when you're doing the limit, you don't even touch this because there's no n's over there. So what you're doing is you're taking the limit of this guy, which is just 1, right? So you end up getting, well, maybe I'll just write 1. I know that seems kind of goofy, but, right? So that's what ends up, what you get. So then now you're going to break it up, right? So if that absolute value is less than 1, it's going to be between, oops, drop the bar, negative 1 and 1. So it's between 0 and 2. So fun stuff. Next unit, we're going to decide at 2 if that's absolutely conditional or divergent. And then at 0, we'll be testing that. So, fun stuff. You're just going to do the bounds in this unit. Okay, so side note. I have this in your notes. So this is the thing, okay? It kind of puts them all on one page. So you can like figure out what to do. This might look like a lot to you, but honestly, my issue is figuring out just which one to use. So essentially, like when I look at any series, and I posted this, I usually decide if it's geometric first. If it is, I'll do it. Okay, that's like pretty easy. It's in a certain form. That's the one where it's like, you know, like 2/3 to the nth or whatever. Then I'll just get the r, see if it's greater than whatever. Geometric. If it's not geometric, my next step is I do nth term. So I take it to infinity, right? Take the a of n to infinity. And then if that equals 0, then I'm like, cool. Now I have all these other options. Okay. So for one of the things you could do is like a comparison test. So you don't need to write this, but this is just my thought process. So I would do, oh, actually, no, before that, I would do, is it a p-series? P-series, that's easy. If it's p-series, perf, okay, then I do that. Okay, so if it's not, so this is like my first branch off, then my second one is see if it's comparative to something, if you can compare it. Something easy, right? So can I compare it to like a p-series, or can I compare it to geometric, or can I compare it to harmonic or something, right? And then I have two choices. Direct is if it's easy to tell if one is bigger than the other. Okay? Maybe it's like 1 over n plus 1. I'll usually use a direct. Or n minus 1, I guess I should say. That would be I do a direct. If it's like kind of more complicated, so it's like less complicated, I'll do limit, but also I tend to do limit anyway, most of the time if I give no choice. So like I'll do these comparison tests for series that are like 1 over n squared plus 1. Like stuff with like little pluses in it, or like n cubed plus 2n plus 1 over n to the 5th minus 3n squared or whatever. That I'll do limit comparison test with. Okay, because it's all n's. There's not like factorials mixed in or like 2 to the n power. There's not like weird stuff in it. It's all kind of the same. So that's when I do those, okay? If it's really fractiony with like factorials and geometrics and n's, like mixed and complicated, I'm going to do ratio. So those are like series, I mean this looks really sloppy right now, but like 2 to the n cubed over like n factorial, something crazy. You know what I mean? Like I would do a ratio test on that one because it's kind of like a mixture of a lot of things versus like the comparison tests. They're all kind of the same. Or like if you had, what would be another one? Well, that I could do ratio. I'm having a brain fart right now. But that's ones that are all like similar, like they're all geometric or all n's. There's not like a mixture of them. I usually do these comparison, and then when it's a mix, I do ratio. Okay, now if it's alternating, actually, last resort integral. I hate integral. I avoid it. I really don't do it if I don't have to. So integral is like the worst one, in my opinion, just because it takes forever. You have to figure out if it's decreasing, positive, continuous. Then you got to do an integral, and it takes forever, okay? Now, if it's alternating, that's an easy test, but what makes everything horrible is you have to decide if it's absolutely or conditionally, right? So like for alternating series, that one's easy, but then you have to just say if it's conditionally or absolutely. So when you're given an alternating series, if it's multiple choice, they'll ask if it's just convergent, and you won't have to deal with the absolutely or conditionally. But if it's on F or Q, you have to go through the whole shebang. Yeah.
Are there any problems that you can only use the integral test for? Or is like there always gonna be a way that you can do it?
Usually they make you do integral test, or they'll do ones that are coming to mind are like this one. Technically you could do a direct, but it's hard to come up with it. So like you have to be pretty creative. So like for that one, I would probably do integral because my u is natural log, my du is 1 over n. So it'd be like not too bad to integrate. But usually integral, if it's got like a function in it, I usually do that, or if they make me. So yeah, that's kind of my gist. This has everything in one of what you need to show. So we're going to just mix them up. So I'm going to give you your quizzes back. So I don't know if you